Okay, these are some more problems from section 4.3 and number 13. We wanted to find the point of inflection. So again, we have to take the second derivative and check for concavity change. So this was my function x e to the x. If I take the first derivative, where you have to use the product rule, first times the derivative of the second, so x times e to the x, plus the second, which is e to the x, times the derivative of the first, which is 1. And we take the derivative of that. Well, this product rule again, plus the derivative of that term. Well, again, this is going to give me x e to the x plus e to the x, first times the derivative of the second, plus the second times the derivative of the first. And then the derivative of e to the x is e to the x. So that ends up being x e to the x plus 2 e to the x, because I've got two of those. Then I can factor out to the e to the x, so this is my second derivative. So I don't have to worry about that being undefined. This is always going to be positive, and this is definitely going to be defined, so I don't have to worry about it being undefined, but it will be 0. Now remember, e to the x is always 0, so e to the x is always positive, so that's not going to enter into my decision. Here I just look at this fact here, x plus 2, and if I solve that for x, or if I set that equal to 0, x plus 2 equals 0, that implies that x equals negative 2. So negative 2 is my critical value. So I can go and I can try values. Now remember, e to the x again is always positive. It's an exponential function, so it's always positive. So I just need to put my values in here. If I put negative 3 in here, I get negative 1, so it's negative. If I put 0 in here, I get 2, it's positive. So I'm concave up, concave down. Okay, since concavity changes, I have a point of inflection. Okay, how am I going to put it? I have to find the y value for the point. So I look at the original function, x e to the x, and I put x e to the x. I try negative 2, put negative 2 in this original function, and I get negative 2 e to the negative 2, which is negative 2 over e squared. So my point of inflection is negative 2 and negative 2 over e squared. And that's the point of inflection because concavity changes there. So you have to worry about. Okay. And the last one, number 15. Well, this is number 15 here. Again, this is on 4.3. Y equals the inverse tangent of x. So again, we want to find the points of inflection. So we have to take the second derivative. So the first derivative is y equals 1 over 1 plus x squared. That's the derivative of the inverse tangent, or arctangent. And that's the same thing as 1 plus x squared to the negative 1. And we're just going to use the power rule to take the derivative of this. Rather than use the quotient rule, we can just use the power rule. So I'll put negative 1 in front, and then times 1 plus x squared to the negative 2, times the derivative inside here of 2x. Okay? And you can see it kind of ends up like, you can see this part of the quotient rule. If you would have used the quotient rule, you would have got the same thing. Negative 2x on top, and then if we, on the bottom, we bring this down to the bottom, we've got 1 plus x squared squared. And again, if you would have used your quotient rule, that's your low d high less high d low denominator squared below, that would be your denominator squared below. But the top would have simplified this quite easily. Okay, so we just take a look at that fraction. Now we know it's going to be 0 when the top is 0 and undefined when the bottom is 0. Well, the bottom is not going to be 0 because this is always going to be positive or 0, so that means that this is going to be at least 1 or bigger. So we don't have to worry about the bottom being 0, so it's not undefined, but the top can be 0 when x is 0. So that's going to be my critical value there. Okay, and we can check some values in here. Y double prime, so y double prime is just this. And again, the bottom is always, the denominator is always positive. So I don't have to worry about checking that. I just check the top for my sign change. If I put negative 1 here, negative 1 times negative 2 is positive. And if I put 1 in here, that's on the other side of 0. If I put 1 in here, that's going to be negative 2 times 1 is negative 2, so negative. So I'm concave up, concave down. So I do have a change of concavity at 0. So I have to put this, we have to find out what value is. So we have the actual inflection point. not just the x value. Well, if I put this in the original function, that was y equals the arctangent of x. So if I put 0 in, what's the arctangent of 0? Well, you know, arctangent of x, this is the angle whose tangent is 0, and that's 0. The tangent of 0 is 0. So that's my point 0, 0. So the point 0, 0 is a point of inflection because concavity changes there. Remember, the angle whose tangent is 0 because the tangent of 0 is 0. All right, just think about, look at your unit circle, and if you take the tangent of 0, you get 0. So that's a solution for this arctangent. Okay, the angle whose tangent is 0 is 0. So my point is 0, 0, 0, and 0. And this is a point of inflection. Why? Because concavity changes there, because I'm going from concave up to concave down. Okay? I hope that helps.